Welcome to day 12. Today, we'll explore one of the simplest yet most powerful tools in Python, the type function. This slide introduces the idea of checking what kind of data your program is handling. It's a small skill that makes a big difference in how clean, reliable, and bug-free your code becomes. Think of type as Python's built-in identity card reader. You ask, "What are you?" And Python responds, "I'm a number," or "I'm text." In real-world AI and data science, understanding your data type helps you prevent costly errors, like passing text to a model expecting numbers. By the end of this lesson, you'll confidently use type to validate your data before using it anywhere in your code. Now, let's see why checking data types is such a big deal. In Python, every single piece of data belongs to a type, a number, text, or a true or false value. Knowing this helps Python decide how that data should behave. Think of data types as containers. You wouldn't store juice in a paper bag. The container must match what's inside. Similarly, in Python, operations must match the data type. For example, adding a number to a word doesn't make sense. Just like trying to multiply a paragraph by 2. In AI projects, this concept becomes critical. If your model gets a text value where it expects a number, it can crash. Or worse, learn wrong patterns. Checking your data types early is like installing a safety net for your code. It prevents confusion, saves debugging time, and keeps your AI workflow smooth. This slide explains how the type function actually works. Here's the idea. You pass a value to type, and Python tells you what category it belongs to. Let's say you store the number 10 in a variable. When you use type on that variable, Python answers, "This is an integer," which means it's a whole number without decimals. In plain English, you're asking Python, "What kind of data is this?" and it gives you a clear answer. The output might look a bit technical, but don't worry, it's just Python being precise. As a best practice, always use type when you're unsure about what kind of data you're working with, especially when reading from CSV files, APIs, or external datasets. This simple check can save you hours of debugging later. Now let's see how type behaves with different data types. First, if you pass a decimal number, like 3.14, Python will tell you it's a float, which represents numbers with decimal points. These are super useful in scientific calculations, or when dealing with precision, like probabilities in machine learning. Next, try a string, such as AI. Python will say it's a string type, meaning it holds text. Strings are everywhere, in usernames, dataset labels, chat messages, and natural language processing. Finally, if you check the value true, Python identifies it as a Boolean type, used for decision-making and logical checks. In AI, Booleans often control model flow. For example, deciding whether to retrain a model or stop early. Each type behaves differently, and using type gives you quick insight into what's really happening in your variables. Now, let's connect this to real-world AI and data science. Before training a machine learning model, you must validate your data types. Why? Because your model expects inputs in specific formats. Numbers for features, text for messages, and categories for labels. Imagine you're building a sentiment analysis model. If your text reviews are mistakenly stored as numbers, the model will fail to understand them. Or if your numeric data is treated as text, the training process could stop entirely. That's why professionals always run a type check before training. It's like asking, "Are all my ingredients ready before I start cooking?" When noting data, you can quickly verify what's text, what's numeric, what's Boolean, and confirm your dataset is clean and ready for training. This one habit can save hours of debugging time and prevent failed experiments. Let's wrap up with a few key takeaways from today's lesson. First, Use the type function to identify what kind of data you're dealing with. Second, checking types early helps prevent hidden bugs and model errors. And third, in AI projects, clean, validated data types mean smoother training and better results. Here's a quick practice challenge for you. Check the types of a list, a dictionary, and a tuple in Python. This will help you explore even more data structures as you go. You've done an amazing job completing day 12. Now you know how to inspect and validate your data, a foundational step every AI engineer relies on. Next up, in day 13, string slicing, we'll explore how to extract specific parts of a text string, a must-have skill for text processing and natural language tasks in AI. Get ready to slice and dice your text data like a pro.